So after today and tomorrow's notes, so then you have a review day and then a test on the statistics stuff, which should be an easy test, I think. And then we'll be reviewing for your final exam. All right, so today we're talking about line of best fit. We want to be able to write an equation for a line of best fit. Write an equation for a line of best fit. And use it to help us predict. So we did scatter plots last week, where you plotted a bunch of data points, okay? And we said, hey, if it's going uphill, it's got a positive association or a positive correlation. It's going downhill from left to right, it has a negative correlation. But what we do when we have data is when it follows this sort of like linear pathway that we can see here, sort of following a line, then we create equations so that we can use it to kind of predict. And so, like, I don't know if you guys go to the pediatrician and they give you your growth charts and stuff. Yeah, you see those like curved lines sort of like this. So that's like standard growth data that they've accumulated all these years to figure out where you fall. Billy is at 0.02% on the growth scale. Whoa, Billy. Oh yeah, for height and weight, which is funny because when he was born, he was like at the 75th percentile because he was a big baby. So, but now he's just so small, right? Okay. Yeah. Anyway, so they've used lots and lots of data over the years to create these little growth scales, and sort of we want to be able to do that at our level as well. So a line of best fit is a line drawn on a scatter plot. A line drawn on a scatter plot that is close to most of the data points. It is a line drawn on a scatter plot that is close to most of the data points. I want to say that it's in between most of them. We can also use that line of best fit to help predict expected weights, for instance, like my kiddo, or expected heights, that sort of thing. So we have, for example here, the graph below shows the relationship between minutes spent studying, so this is the study time in minutes, and the test scores for a math class. Which line best describes the data, best represents the data? Graph each line to justify your answer. So we're going to do a little bit of graphing here. Maybe you've got some different colors. You don't really need different colors. But there's one thing I want to talk about here. In order to, gentlemen, ladies, graph these lines, we want to make sure that our scales are counting at the same rate. So when we look at these boxes, what is each box counting by? 5, yeah, this is 5, 10, 15, 20, 25, 30, 35, 40. And same thing here, 50, 55, 60, 65, 70, 75. So they're counting by the same scale. So that's really important so that we can graph these lines. So I'm going to graph line A here. So y equals 2/3 x plus 50. I don't know if you remember because it's been a while. This is a great sort of topic to sort of end on here. This is in the form y equals mx plus b. Do you remember that? Y equals mx plus b. What did m stand for? It's slope. It was slope. It's the rise over the run. And then what does B stand for? The starting point. It's the beginning point. B for begin here. All right, ladies. So if I'm going to graph this, I'm going to start here at 50. So I'm going to put a dot right at 50. And then the slope is up 2 over 3. And this only works because we're counting by 5s, and that's in both directions. We're counting by 5. So from 50, I'm going to count up 2 boxes over 1, 2, 3 boxes. Up 2 boxes over 3 boxes. And so once I've got that, I'm going to use my protractor, my straight edge, to connect those dots that I graphed. So this is line A right there. All right, line B, again, it begins at 50, so I'm starting at the same point right here, and the slope it has is up 3 over 2. So from 50, I'm going to count up 1, 2, 3 boxes and over 2 boxes. Up 1, 2, 3 over 2. And so this is my line B, and I'm going to use my protractor to connect a straight edge. So there is line B. So there's line B. Which line is better? Is line B closer to the data, or is line A closer to the data? A is a little bit better. Would you call A good? No. Not really. All right, let's look. Let's look at line C. Line C begins at 55. So here's my starting point at 55. And again, the slope is up 2, right 3. So I'm going to go up 2 boxes, right 1, 2, 3. Up 2, right 1, 2, 3. So I've got my 55. There we go. All right, and there's line C. Oh, I shouldn't be circling all of these. All right, which line's the best, A, B, or C? C, okay. All right, and then line D, again, starts at 55, and it says go up 3 and over 2. So I'm going to start at 55 again. And this time I'm going up 3 and right 2 boxes. So up 1, up 2, up 3, right 2. Up 1, 2, 3, right 2. Okay, so started at 55, and it's going up 3 and right 2. So there is line D. Okay, so these are our 4 choices for a line. Which one would you say is the best representing the data? Yeah, line C is the one that best represents the data. So I'm going to highlight that in red. So there is line C. And line C, you can look at the data points and you can see there's like above, below, above, below, above, below, above, below, above, below. It's sort of in between. There's a few points below and a few points above. Do you see how it's sort of between all the data? So this is a good approximation of the data. Now, we're going to get some practice finding the line of best fit. So we're going to draw a line that is close to most of the data points. It should split the data. Then we're going to find the slope between any 2 points. Gentlemen, I hope you're paying attention and you're not on your computers because you're going to want to know how to do this. And we're going to identify the y-intercept, and we're going to be able to write the equation of the line. So here we have our first problem we're going to do today. The graph below shows the ages and weights of 12 babies. So this is their age in months and on the y-axis we have their weight in pounds. And we want to find a line of best fit, and we're going to write an equation for the line of best fit. This is why we have our protractors here. And so if I just draw my line way up here, is that a good spot to draw my line? Oh, it's above the data. It doesn't go through the data. It doesn't split the data. We want the same number above, the same number of points above the line as we want below the line. So I'm just going to slowly move my protractor so that it's sort of in between the most amount of data points that I can manage here. And so I think that looks pretty good. So I'm going to draw my line. So that looks about like there. So there's my line. We want to use this line to help us predict what's going to happen in the future, but also understand the difference between data points on the line and actual data. Now, to write the equation, we want to find the slope between any 2 points on our line. Do they have to be data points, or are they just supposed to be on the line? Just on the line. And so, maybe, what is that point? 8. It looks like I'm going through 0, 8. And then, let's see, another good point, maybe, and yours might be a little bit different. I guess I am kind of going through this point right here. It happens to be on the line, happens to be pretty nice. So I have 2 points that I'm going to use. So if we want to find the slope, I need to pick 2 points. And so I'm going to use the point 210, and I'm going to use the point 0, 8. So we're going to pick 2 points, and then we can figure out our slope. Do you remember the slope formula? It's y2 minus y1 over x2 minus x1. Do you remember that formula? That was a long time ago. I think that was first semester, I think. So that was a really, really long time ago. But what we want to do is we want to subtract our y-coordinates. And so our y-coordinates are the 10 and the 8. So we're going to do 10 minus 8. You'll notice that I subtracted from the right point to the left point. And then I have to subtract my x-coordinates in the same direction. So I'm going to do 2 minus 0. All right, so that is, what is 10 minus 8? 2 over 2, and what is 2 over 2? 1. All right, so that's my slope. And my B, where did my line begin at? 8, yeah, my B is 8. The y-intercept, where it intercepts the y-axis. And if I have my M and my B, then I can write my equation. Here's my equation. Super easy. Y equals MX plus B. Y equals 1x plus 8. So I just take my 1 and my 8 and plug them in to y equals MX plus B. That is a long time ago that we did that. Okay. Now, when we have a line of best fit, what we can do is we can use it to estimate the weight of a baby that is 12 months old. You'll notice at 12 months right here, I don't have a data point, but we can use our line of best fit to kind of approximate a baby's weight. So at 12 months old, all I have to do is say, hey, x equals 12. And we're going to go ahead and plug it into our equation. So y equals 1. Plug in our 12 and add 8. What's 1 times 12? Plus 8. Yeah, it's about 20 pounds. And so all we're doing is taking 12 and plugging it into our little model. Is everybody's line going to be the same? No, it will be on Delta Math, though, because I gave you a very special problem. Okay? All right, turn the page. We're going to try a couple more. All right, number two. Beth started a new bank account. The graph below shows the monthly balance of the account in the first year. All right, let's see. So I'm going to try and find a line that goes between a lot of the data. This line is a little too low. This line, oh, that looks a little better. This is pretty good, maybe. Oh, that looks a little high, actually. Sometimes you draw your line and you're like, nope, that wasn't it. Oh, I think that's pretty good. All right, there we go. All right, I think this is a pretty good line. So I want to write the equation. Y equals mx plus b. To write the equation, I need my m and I need a b value. And so do we see a point where my line begins? Yeah, 350 right there. So it's a good spot. 0, 350. And then there's another point. Ooh, here is a very good point. Right here, I'm choosing this point. It's not a data point, but it's a point on my line. Why did I choose this point on my line? It's crossing, it is in the middle. It's crossing the line on a grid point, like it's just crossing super nice. So that's the point 6 and 450. So those are my 2 points that I choose, and yours might have different points, but. All right, so I'm going to calculate my slope. So I'm going to subtract my y values, 450 minus 350. And then I'm going to subtract my x values, 6 minus 0. What is 450 minus 350? 100. And 6 minus 0 is 6. I think I can divide both of those by 2, so that's going to be 50 over 3. And what is my b? Where's my beginning point on my graph? 350. That is the y-intercept. All right, and so I can write my equation. Y equals mx plus b. My m was 50 over 3. Don't forget your x plus my y-intercept. So that's my equation that I can use. And you guys are going to be doing this today too. You have to write your equation, and then you're going to have to do some predicting. So now we want to estimate the account balance. So the account balance is the y value of the account after 2 years. So years, we were in months. What do we have to do? So 2 years is how many months? Yeah, so that is x equals 24 months. All right, so what we're doing is we're going to go ahead and use our model, and we're going to plug it in. So that's going to be 50 over 3, plugging in a 24 for 24 months, plus 350. And I can use my calculator if I want to. So 50 over 3 times 24 plus 350. And I get $750, roughly. Now, it is important that we understand the difference. If I were to ask you, hey, what does, I'm going to do this in orange. What does this point that I've circled in orange, what does that mean? What is this point representing that I've circled in orange? What does it mean? It's a bank account. What is that point talking about? Give me more details. Okay, so how much money is in the account? Okay. Very good. There's $450 in the account after 4 months. Okay. That is an actual data point. That is an actual thing that happened. That is real data, okay? But when we use our little expectation here, 24 months is way out here on this line, way out there. Is that an actual point? On an actual data point? No, it's an estimate. It's an expected amount, all right? It's expected, but it's not an actual. Does that make sense to you? An actual data point versus something that could be? Okay. So you want to read carefully when you're answering questions today. All right, last one here, number 3. A 10-inch tall candle is lit. The graph below shows the height after each hour. All right, so this is pretty tight here. I'm thinking that it's going pretty straight right here. There we go. So there's my line of best fit, it looks like. So again, our job is to write an equation. That's y equals mx plus b. I need to find my slope. So I need to pick 2 points to find my slope, ladies. So all of your graphs are going to have a real nice y-intercept for you to choose. So I have the point 0, 10, that's 10 inches tall. And then I also have, I'm going to use, again, this point right here, which is not a data point, but it's a point on my line, that at 6 hours, it was 8 inches tall. And so there's my second data point. And now I can find my slope. So I'm going to do y2 minus y1, so 8 minus 10 over x2 minus x1, 6 minus 0. 8 minus 10 is what? Negative 2 over 6, which reduces to negative 1/3. Why is this slope negative? Because it's going downhill, yeah? So this is a negatively sloped line, so we should have a negative value there. And what is our b value? 10, that is the y-intercept. And so we're going to write our equation. Y equals my m, negative 1/3 x plus 10. So there's our little equation, y equals mx plus b. All right, and then it says estimate. So we're going to predict the height of the candle after 15 hours. What are we supposed to do? Which axis is 15 hours on? The x, yeah, it's the x-axis, so that means x equals 15. So we're going to plug 15 into our equation. Negative 1/3, plugging in the 15, plus 10. What is negative a third of 15? Negative 5. Plus 10? 5 inches. So that candle after 15 hours is now down to 5 inches tall. All right, ladies and gentlemen, you have to do all of this today. You're going to write an equation, and then you're going to plug something in. But it doesn't work you through this. You have to do it, though. Write your equation of your line of best fit, and then you're plugging in a value. It's a delta mass.